Okay, the final notes for today is the mean absolute deviation. So again, this is talking about spread. So this is the third thing that talks about how far data is spread between basically the minimum to the maximum. So this is called the mean absolute deviation, or called the MAD. It might make you a little mad, but only if you have a lot of data. So this is numbers that are very close together are going to have a smaller MAD because they're not as spread apart, and the bigger numbers are going to have a higher MAD. So the very first thing what you're going to do is you're going to find the mean of the data. So we did that on the front side of our notes. Then we're going to take the positive difference, and remember difference is subtraction, from the mean in each data point. Then we're going to find the mean of the differences. So this won't make sense until we dive into a problem. So we have this fancy chart to try to stay organized. So the very first thing is says data. So we're actually going to write every single number in this chart. So we're going to say 5, 9, 10, 4, and 11. Now this says sum, so we add them all together, and we get 39. We have 5 numbers, so we go ahead and divide 39 divided by 5. We get 7.8. So that's the very first step. You're just finding the mean like we always have. Now the second column says the deviation from the mean. So deviation, we're just going to say how far away is this number from the mean. So we're going to just write the mean in every single box first. So now remember, we're going to take the positive difference. So the first thing is we're going to take the difference, then the positive is going to come in later. So we're going to say minus 5, minus 9, minus 10, minus 4, and minus 11. Okay, so go ahead and pause the video and try to subtract all these and put the negative if it became negative. Okay, so you should have got these data, or these differences. Now if you notice, like, these are positive, these are negative. That's when the word in front of difference is super important. So it says positive. So anytime we see a negative, we're actually going to turn it into a positive. So we're going to basically take the absolute value of all of these. So these should all be positive. That's why it's called the mean absolute and then deviation. So deviation is how far away it's from the mean. We're taking the absolute value of the differences. So now we're going to go ahead and add all these together. We end up getting 13.2. We're going to divide that by 5. And we get 2.64. So this number right here tells us that the average of all these numbers are relatively about 2.64 points away from the mean. So it's actually pretty close. So now we're going to go ahead and do number 2 a bit faster. So data, we're going to write all of our data. We're going to add them up all together and we get 47. We still only have 5 numbers. Sometimes you might have 5, you might have 10. So again, we're just taking the mean. So when we divide this, we get 9.4. So now we're going to take our mean. We're going to write that first. And then we're going to subtract every single one of these numbers. Okay, so go ahead, pause the video, and come back with all your differences. Okay, so these should be your differences. So now we're going to make them all positive. Okay, we're going to add them all up. We get 15.6. Again, we still have 5 numbers. And we end up getting with 3.12. And that's all the MAD is doing, or the mean absolute deviation. So go ahead, pause the video, do 3 and 4, and then come back to see if you did it correctly. Okay. So you should have got the mean absolute deviation for number 3 is 1.44, and number 4 you should have got a 1.2. Now the questions on the bottom is asking which set of the numbers seem the closest together. Well, if I don't have the MAD, or the mean absolute deviation, to help me, so if we quickly glance at all the data sets, this is asking which ones do you think that the numbers are relatively close together. So there's not a lot of gap between data. Well, the easiest way to figure that out is just look at the range. Well, in this case, our biggest number is 11. Our smallest number is 4. So our range is 7 on this one. This one, our largest number is 14. Our smallest number is 3. So this range is actually 11. So between these two, this one has a higher range. So this one's spread out more. So that means that these are closer together because they had 7. Now this one, my highest number, my maximum is 12. And my minimum is 6. So this one has a range of 6. So now between these two, this one had 7, and this one has 6. So this one's actually closer together. Now this one we have maximum is 10, our minimum is 6. So our range in this case is 4. So we just figured out that this had a range of 7, this has a range of 11, this has 6, and this has 4. So this is saying that the numbers are really close together because they only range between 4 numbers. So we got 10 is the highest all the way to the lowest, which is 6. So we're going to say, based off just the range, we're going to say the closest numbers are going to be data set number 4. Now let's check their mean absolute deviation. Well, this one has 2.64, 3.12, 1.44, and 1.2. So data set number 4, according to the mean absolute deviation, is actually closer to. So before, I was saying that the smaller the number, that means the closer the numbers are together. Now the opposite, the farther apart they are, the larger they are, the largest mean absolute deviation it will have. So we look at all 4, we see that the biggest one is right here. So it had the biggest range, and it also has the biggest mean absolute deviation. So that means that all these data sets deviate from the mean the furthest than any one of these. So we're saying data set number 2 is the furthest apart, and it also has the largest mean absolute deviation. So these are the end of the notes.